In this lesson, we are going to be learning about congruency and similarity. So we're going to start off by comparing the differences between congruency and similarity to help us understand what is congruency compared to similarity. So first of all, congruency is when we have two shapes that have the exact same side length and the exact same angles. Whereas similarity is when we have two shapes where corresponding angles are the same, but the corresponding side lengths are not quite the same. They are proportional, not identical. The symbol for congruency is kind of like an equal sign with a little squiggly on top. So here's an example. We have triangle ABC is congruent to triangle DEF. Whereas similarity is just a little squiggle sign without the equal sign. So we have triangle KLM is similar to triangle HIJ. So let's look at my first example of two congruent triangles. Here I have angle A and angle D. They both have one arc. So that means they're going to correspond to each other, and also it means that these two angles are equal or congruent. Now let's look at angle B. Angle B has two arcs. Well, angle E also have two arcs. So angle B and E are corresponding to each other and are equivalent. Now I'm going to look at angle F. It has three arcs, and angle C has three arcs. That means both of these angles correspond to each other and are equivalent. They are the exact same angles. Now, I'm looking at side CA. Side CA has a little tick on it. Side FD has a tick on it, meaning they are the same measurement of length, which means these two sides are equal. Now I'm going to look at side DE and side AB. Side AB has two ticks, side DE has two ticks, which means both of these sides here are going to be the same. They're the same side length. Now we look at side FE and side CB. These two sides are also corresponding because they're between the same angles, and then we look at it, they both have three ticks, so they're also equal. So if I look at this example here, these two triangles have identical angles and all sides are the same. So in this example, it's very key to notice that every angle and its corresponding angle are equivalent. Also, every side and its corresponding side is equivalent as well. And that's what makes it congruent. Now let's take a look at our similar triangles. Here, angle K corresponds to angle H. They have the same arc, and they're going to be equal to each other. Angle J corresponds to angle M. They have the same arcs, but these two both have two ticks. So these correspond and equal to each other. And if we have two angles that are the same, most likely angle I and angle L are going to be the same as well. But if I look at that, if I look at something here, let's look at the length of HI. HI it corresponds to KL because it's between the two corresponding angles, the identical angles. But HI does not equal to KL. Same with HJ. HJ does not equal to KM. But a very important thing to look at is these sides here must be proportional. They must have the same proportional. So if HI is twice as long as KL, then HJ should be twice as long as KM in order for them to be proportional. Same with JI should be twice as long as ML. Now let's say HI was 3 times as long as KL. That would mean HJ would have to be 3 times as long as KM, and so on. So what this last example showed us is that a similar polygon is whenever we have an enlargement or reduction that has the same scale factor applied to all sides. We say that the original and new polygon are similar and proportional. So every side must be proportional to its corresponding side. Similar polygons have the same angle measurements, but key thing here is they do not always have the same side lengths, although the side lengths must be proportional. So here at the bottom we have two similar polygons. How do I know? Well, I could look at angle D. That's going to be equivalent to angle P. Angle A corresponds to angle M, and we're going to say they're equal. Angle C corresponds to angle O, and angle B corresponds to angle N, and so on. Now, how do I know those corresponds? Well, let's look at it this way. All of my side lengths are actually proportional to each other. So if I look at side AD is 6 inches. That corresponds to side PM, and side PM is 4 inches. Now the scale factor from the both sides is going to be 3/2. Now let's check this out. DC is 6 inches and PO is 4 inches. That is a scale factor of 3/2 again. Now I look at side CB, that's 3 inches. Side ON is 2 inches. That is once again a scale factor of 3/2 if we're going from the little one to the big one. Now let's look at AB. AB and MN are corresponding sides. I have 9 inches on AB and I have 6 inches on MN. Once again, that is a 3/2 scale factor. So in this case, we have all angles that are equal and all sides are proportional, meaning that these two polygons are similar. So now what we want to do is figure out what are the corresponding sides and angles for these two figures. So I'm going to first look at my angles. My smallest angle is angle C in the big triangle. The smallest angle in the smaller triangle is going to be angle D. So I'm going to have to look at it and say that angle C corresponds to angle D. Now I look at angle A, it is my middle angle. So is angle F. So I'm going to say angle A corresponds to angle F. Now let's look at B. B is almost a right angle, and we're going to say E is almost a right angle. So I'm just going to put a right angle symbol there. So I'm going to say now angle B corresponds to angle E. Now, let's look at side AC. Side AC is between my 1 arc and my 2 arc angle. Now, which one here on this next triangle is between the 1 arc and 2 arc angle? That's going to be DF. So AC corresponds to DF. Now let's look at side AB. AB is between right here. We have my 2 ticks and we have my square. So between 2 ticks and squares, AB corresponds to EF. And then we have my last one. We have BC and we have ED. So then BC corresponds to ED. So here are the key properties that you must always know for similar polygons. When two polygons are similar, once again, their corresponding angles must be equal, and their corresponding sides must be proportional. So whenever we know two polygons are similar and we're trying to find a missing side, we're either going to use proportional reasoning or we could solve algebraically. Sometimes one is simpler than the other. We're going to look at 2 examples here. So my first example of AB over 12 is equal to 1 over 3. So how do I solve for AB? I could do it 2 ways. I could either just multiply both sides by 12 to get AB by itself, which will give me 4, or I could look at what am I multiplying to get from one side to the other. So in this case, I'm dividing by 4 to get to 3, so then I must divide by 4 to get to 1. So then to go in the opposite direction, I have to do the opposite thing, times by 4, times by 4. So 1 times 4 is 4, so the same thing as AB is equal to 4. Or like I said before, we could isolate for AB, and it says divide by 12, so we do the opposite as multiply by 12. So I go 1 over 3 times 12. Let's take a look at B. B, it's a little bit tricky to figure out what multiplied by 1.8 is equal to 24. Or I'd have to go 24 divided by 1.8. That's not an easy division. So instead of doing proportional reasoning, I'm actually just going to solve this algebraically. So first thing I'm going to do is multiply both sides by CD. So I'm going to end up getting 1.8 over 2.4 is CD is equal to 24. Next, what I'm going to do is I'm just going to isolate for CD. So I'm going to times both sides by 2.4 and divide both sides by 1.8. So for this part here, I'm going to look at the common factors. And I'm going to move the decimal place for each of these by 1. And just look at my factors. I'm going to factor each one. So 24 is the same as 3 times 8, which is 2 times 2 times 2. And 24 again is 3 times 2 times 2 times 2. Those are the common factors. And the bottom we're going to have 3 times 3 times 2 is 18. So now that I have my prime factors, I'm going to start canceling off. 3 divided by 3 is 1. 3 divided by 3 is 1. 2 divided by 2 is 1. And I'm going to be left with, altogether, 2 times 2 is 4 times 2 is 8 times 2 is 16. And then times 2 again is 32. So I'm going to be left with 32 is equal to side CD. So in our next examples, we want to see if the shapes are proportional, and if they are proportional, then whether or not they are similar. So let's first take a look at A. I look at my scale factor for, let's say, this first side over here. We have 2 and 4. These sides are corresponding to each other. Now, if I look at this, I'm going to go, my image is just 4 divided by 2. My scale factor is equal to 2. That also works for my next side here with this 2 and this 2, or this 4. We have a scale factor of 2. But if I look at the bottom, if I times this 3 by 2, I am not going to get 5. This should be 6. So proportionality is not maintained throughout this shape because 3 times 2 does not equal to 5. So these are not similar. Now let's take a look at B. Let's see if proportionality is conserved. So here, I'm going to look at, we're going to say this is my object, and this is going to be my image. So I'm going to say 3 divided by 2 is going to be my scale factor. Now, let's see if that works for these. So does 10.5 divided by 7 equal to 3 over 2? Is that the same proportion? If I simplify this, yes, it is the same proportion. So these are the same proportion, so then these two here are similar. Okay, now let's look at this one here. My next example, I have all sides are proportional. We're always halving each side. So we have 2 goes to 1. 2 here goes to 1. 2 goes to 1. 4 goes to 2. So we're always halving. The proportions are correct. 3, 1.5. But my angles are not correct. This angle here is not equivalent to this one. This angle here is over 180, whereas this angle over here is less than 180. Therefore, these are not similar. So if we were to look at the scale factor of areas of 2D shapes, something interesting will happen. Let's take a look at two similar rectangles. So let's say I draw one rectangle like this, and we're going to have another rectangle that's bigger like that. Now, we're going to say this one here is 1 by 2, and this one here is going to be 4 by 8. So when I look at my scale factor between each of them, it's going to be equal to, we're going to say this is my image, this is my original. So we're going to have 4 over 1, or 8 over 2, which is the same as 4 over 1. It's pretty simple if we're just looking at edges. So the scale factor between them of edges. Now, what about if we compare their areas? So let's look at the area of 1. So the area is equal to base times height, which is equal to 2 times 1. And that's going to give me 2 units squared. Now, let's look at my area of the second one. My area of the second one is, again, base times height, which is equal to 4 times 8. This gives me a total of 32 units squared. So now let's look at my scale factor of my area. I'm going to put a little a there to represent area. That is the same as my image is 32 all over 2. Which gives me 16. So when I look at my scale factor of my area, 16 over 1, compared to my scale factor of my edges, I have quite a difference. So what we must do if we're trying to find the scale factor of an area is square the scale factor of the edge. Now, why is that, you might ask? Well, if I look at it here, we are applying the scale factor for my image twice. We're multiplying this one by 4, and we're multiplying this one by 4. So we're multiplying the scale factor by 4 twice. So if we're multiplying the scale factor twice, that's the same thing as squaring the scale factor. So that is why when we have the scale factor of an edge, to find the scale factor of an area, we just square the scale factor of the edge, because we're technically multiplying that edge scale factor twice into my new image. So let's take a look at this as another example with the formulas. So my scale factor for each edge was multiplied by 4, right? So let's look at my original. We're going area is equal to base times height. Now, this is going to be my original. This is going to be my image. My image, area is equal to 4 times the base multiplied by 4 times the height. So in other words, it is 16 base times height, which is the same here. This is just base times height. So my scale factor is actually 16 times bigger. Or it is, we say here, in other words, it is 4 squared base times height. So it is squared my original scale factor of my edge.